Good evening, children.
Good evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good evening. Yeah, we started with volumes and surface areas in the last class, but most of you did not attend. Today also, a few of us are not here. Well, the Monfort students will not attend today because they have a different exam tomorrow. Now, I have actually finished 11.1, but I'll just do a quick brush up so that children who missed the session can, get something so that you can, work out the answers later with the help of the images I'll be sharing on WhatsApp. So coming to the formulae, the cone we'll be studying about is a right circular cone. I've shared my screen. Is it visible to all of you? And am I audible?
Yes, ma'am.
Okay. Right circular cone. Okay. So this is a right circular cone. The base is circular. The base is circular. This is the radius of the base. This is the height of the cone. The radius of the base and the height of the cone, they meet at right angles, which is why it's called a right. Right meaning right angle, 90 degrees. Right, circular because the cone has a circular base. Right is 90 degrees because the radius and height, they meet at right angles. Circular because the cone has a circular base. And cone, right circular cone. Now, a cone has two surfaces. One flat surface, one flat circular surface, flat circular base, and a curved surface. It has two surfaces. It has a flat circular base, that's one surface, and the other surface is the curved surface. This one, this is a curved surface. This one is a curved surface. The volume is the capacity of any vessel or a container. Now, when we say volume of a cone, it's the amount of liquid the cone can hold. So, if you hold the cone upside down like this, supposing it's a conical vessel, it's a conical vessel. Okay, so you hold it upside down like this. You cannot place it on the table because it doesn't have a broad base. So this is an inverted cone. This is a cone. This one is an inverted cone. Inverted cone, because when we say cone, it has to like stand on its base like this. This is a cone. This one is an inverted cone. So your ice cream cone is an inverted cone. So when we say volume of a cone, it's the amount of liquid the cone can hold. And then you have area. We have the curved surface area and the total surface area, which is the curved surface area plus the area of the circle. Total surface area is the curved surface area plus the area of the circle. So if I call the curved surface area, if I call the curved surface area 1 and this one as 2, 1 plus 2 is total surface area. Volume is given by the formula 1 by 3 pi r square into h cubic units. Curved surface area is equal to pi RL square units. And the total surface area is pi R into R plus L. Why? Because what is total surface area? It is the curved surface area plus the area of the base. Area of base. So curved surface area is pi RL plus the area of the base, pi R squared. So pi R is common, L plus R. Or you can even say pi R into R plus L. R plus L square units. And what is L? L is a slant height of the cone. L is a slant height of the cone. This one, which is the hypotenuse, is a slant height of the cone. Okay, this one is a slant height. This is the perpendicular height, this is radius, and this is the slant height, L. Now, the relationship between L, H, and R, okay? L square is equal to H square plus R square. It's exactly Pythagoras theorem. The square on the hypotenuse, L square, is equal to the sum of the squares of the other two sides, H square plus R square. So if you're given the values of any two, so supposing you're given the values of L and H, you can find R using this relationship. If you're given R and H, you can find L. If you're given L and R, you can find H using this relationship. L square is equal to H square plus R square. You can also write it as L is equal to square root of H square plus R square. L is equal to square root of H square plus R square.
Good evening.
Yeah, good evening, Anita. Just a second. Okay, so that's about the formulae. Now see the first one. You'll have to find the curved surface area. Curved surface area. So CSA, curved surface area of a cone, is given by the formula pi RL. And you're given the value of R. You're also given the value of LC, a slant height. This is L. L is 10. And base radius R. R is 7. So L is 10. R is 7. And the formula to find the CSA is pi RL. So substitute and you'll have to calculate. In this one, we are given the height of the cone. See here, height of the cone, H, 16. Radius, 12. You'll have to find the CSA, the curved surface area. The formula is pi RL. You need the value of R and L. But in the question, we have the value of H and R. We don't have the value of L. So we have to find L. So we know that L is given by square root of H square plus R square. Square root of H square plus R square. Why should you find L? Because in the formula it is pi RL, pi into R into L. We have R 12. L is not given to us in the question. So we'll have to find L. And L is 20. Then substitute in the formula. And pi, you'll have to take pi as 3.14. So 3.14 into R 12 into L 20. You should also find the TSA of the cone, total surface area. Total surface area is pi r into r plus L. 3.14, radius is 12 into 12 plus 20. 12 plus 20 is 32. And this product is 1205.76. In this question, you see a corn cob. Okay, you see a corn cob. Now, the grains of the corn cob, okay, or the kernels or the grains, the kernels or the grains of the corn cob, they are arranged on the CSA of the, okay, before that, so this corn cob is not a perfect cone, but it's somewhat like a cone. It's somewhat conical. It's not a perfect cone, but it's somewhat conical. So we'll take it as a cone. Now, where are the grains or the kernels, the corn kernels arranged? They are arranged on the curved surface area of the corn cob. The bottom part, you'll find the stack. The bottom part of this corn cob, you'll find that stack, no, the stick thing which is attached to it. There you will not find the grains. That so where the stick is attached, that will be a circular portion. There you will not have any corn cobs. You will not find corn cobs there because the stalk is attached to that part of the corn. So you need to understand this as the grains of the corn are arranged on the curved surface area. On the curved surface area. A very simple question. It's given that on every 1 centimeter square, there are 4 grains. Okay, so supposing the CSA of this cone is, say, 20 centimeter square. Okay, it's given in the question that 1 centimeter square of this corn cob carries 4 grains. 1 centimeter square, there are 4 grains. 1, 2, 3, 4 grains. So they want you to find how many grains are there on this entire corn cob. Similar to the cost of 1 notebook or 1 pencil is 4 rupees. What is the cost of 20 pencils? So 20 into 4. In the same way, 1 centimeter square of the corn cob carries 4 grains. So supposing the curved surface area is 20 centimeter square. So it will carry 20 into 4, 80 grains. 80 grains. And why curved surface area? Because the grains are arranged on the curved surface area of the corn cob. And it's somewhat conical. So to find the curved surface area, you need to use a formula pi RL. In the question, you have the radius 2.1, radius is given, and the height, that is the whenever it is height, it's always a perpendicular height. If it is slant height, it will be given slant height. If it's given simply height, it's always H, not L. Okay, so radius is given and H is given 20, but we need L, R and L. So we'll have to find L using the formula. L is equal to root or the relation, root of H square plus R square, 20 square plus 2.1 square. Okay, so and then you'll have to recall how to find the square root of 404.41, 8th standard by the long division method, and you get 20.11. Square root by the long division method. You'll have to pair after the decimal point in this direction, before the decimal point like this. So 4 stands alone, 2 2s are 4, 0. The next pair comes down, double the quotient. Whatever you add here, you should add the same thing here. So even if you put 1, it's going to become 41, but it's only 4. So 40. 40 into 0 is 0. The remainder is 4. Places decimal point. The next pair comes down. Double the quotient, 20 into 2, 40. Whatever you add here, you should add the same thing here. So it's 1, 1. 401 into 1 is 401. And the remainder is 40. You can continue the division like this. Add 2 more zeros here and bring them down. So 2 more zeros. Double the quotient. 201 into 2. 402. 402, right? Yeah. So it'll actually be 0, 2.10. Okay. Or you can just stop here, children. Just ignore this one. Because since we have 404.41, you can continue the division, nothing wrong. But because we have 404.41, 20.1 is enough. I'll just change this later. That's enough, actually. So you can stop there. You can start with this 20.1. So that's how you find the square root using the long division method. Let's change it in the presentation later. Yeah, so now that you've got the value of L, pi r L, so the curved surface area is this one. Now it's like one pencil, 4 rupees. So many pencils will be this one into 4. In the same way here, 1 centimeter square carries 4 grains. So many centimeter square will carry 132.73 into 4. So approximately the entire corn cob has 531 grains. Approximately the entire corn cob has 531 grains. Very, very simple question. If each centimeter square of the surface of the cob carries an average of 4 grains, find how many grains you would find on the entire corn cob. So things to remember is the grains are arranged on the curved surface of the corn cob. So you have to find the curved surface area. Formula pi r L. L not known. So you should find L. Once you find L, find CSA, and then 1 centimeter square, 4 grains. 132.73 centimeter square will have into 4. So that gives us 530.92, which is 531 approximately. These are very direct. Diameter is given. Diameter is 10.5. So radius will be 10.5 by 2. Diameter is given, so find the radius. And slant height is given. Directly slant height is given. So you know radius, you know slant height. And you should find the CSA, curved surface area, pi r L. Direct question. Yeah. So this is also a direct question, children. You're given the slant height and the radius, meaning if the diameter is given, diameter by 2 is radius. So simply you'll have to substitute the values in the formula and calculate. Yeah. In this question, you have to find the radius of the cone. You'll have to find the radius of the cone. And to find the radius of the cone, what is given? The curved surface area of the cone is given to you. The curved surface area of the cone is given to you and the slant height is given to you. You have to find the radius. See, normally radius and slant height is given and you should find CSA. The direct question is radius is given, slant height is given, find the CSA. Here, they've given you CSA. and the slant height, and they want you to find the radius. Am I audible to all?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So normally we're given radius and slant height and asked to find the curved surface area. So here you're given the curved surface area, you're given the slant height, and you're asked to find the radius. So how do we do it? So write what is given. You're given no CSA is 308, write that. CSA is equal to 308. Now what is CSA formula? Pi RL. So pi RL is equal to 308. So this is the equation. This is the equation. CSA is 308, meaning pi RL is equal to 308. Why? Because this is formula to find CSA. Now substitute. Pi is 22 by 7. R is R because we'll have to find that. And L is 14 given is equal to 308. So solve this and find the value of R. You'll have to simplify, cancel and all that. And R is 7. Now we found R. Next, find TSA. Formula. Pi R into R plus L. So you know R is 7. And L is given in the question 14. Just have to substitute and calculate. So when it comes to a tent, we need to remember that the material, whatever the tent is made of, whether it is made of canvas or, tarpaulin. So there are different materials which are used to put up a tent. Whatever is the material is used only to make the curved surface area of the tent. See, we understood that a cone has two surfaces. It has a flat circular base and a curved surface. So when a conical tent is put up, the material, canvas or whatever material, is used only to make the curved surface area. The circular part, which is the ground, the circular part will be the ground, no? On the ground, the material will not be cut in a circular shape and put on the ground. No, the ground is left as the ground itself. So you can maybe use a stool or a chair or spread a mat and sit. The material canvas or the tarpaulin is not cut and put on the ground. So remember that whenever a tent is put up, the excuse me, the material, whatever material is used to make only the CSA, the curved surface. Okay. So 10 meters high. 10 meters high meaning H is 10. Radius 24. 24. Radius 24. Find slant height. So this is the height of the conical tent. This is the radius of the base. You should find the slant height. So you have this relation. L is equal to root of h square plus r square. Substitute and find the value of L. Then you'll have to find the cost of canvas. So to find the cost of canvas, first you should find the area. See, supposing you have to find how much money you'll be spending on books. Okay, how much money will you spend on books this year? For that, you should decide how many books you're going to buy. Or what are the books you're going to buy? How much are you going to spend on fruits? For that, you should first decide what you're going to buy. You're going to buy apples, you're going to buy mangoes. What are you going to buy? So similarly here, find the cost of canvas. Cost of canvas, okay, you can find the cost only if you know how much canvas you have to use. For that, you should find the CSA of the tent. So the CSA is this fraction. You find it using pi RL. Formula pi RL, pi 22 by 7. R is 24 and L is 26, which we just found. You can just leave this fraction. Don't find the decimal value and all that. Now again, it's very simple. Now, 1 meter square of canvas is 70 rupees. So 2 meter square will be 140 rupees. 3 meter square will be 210 rupees. 4 meters square will be 280 rupees, and so on. So if 1 meter square costs 70 rupees, how much will this meter square cost you? So it'll be into 70. So 7 ones are 7 tens are, and 1,37,280 rupees. So to find the cost of canvas, you should find the curved surface area of the tent. Why is the CSA? Why not TSA? Because the canvas will not be used on the floor. It will be used only for the curved surface. So you should find only the curved surface. Where will you use the canvas? Only to make the curved surface area. So find CSA using pi RL, and then 1 meter square is 70 rupees. So many meter square is equal to that into 70. In this question, it's like you have to go to the shop and buy tarpaulin. Tarpaulin is another material which is used to make tents. So if you have to stitch a shirt or a pant for yourself, so you know what length of material you need. Maybe you'll need about, like maybe 1.5 meters, 1.5 meters of pant material, or some 2 meters of shirt material to buy to make your shirt. You have to stitch a shirt or a pant for you. So in the, when you go to purchase a material in the store, you'll have to specify the length of the material. The material will be rectangular. The material is rectangular. The fabric in the store, in the shop, will be rectangular. Okay. And you cannot decide the breadth of the fabric. That is fixed. You can only decide the length. You can say, give me 1 meter length, 2 meters, 3 meters. The fabric is rectangular, but you cannot decide the breadth. The breadth is fixed. Different material come in different breadths. So the breadth is fixed. You can only, request for the length. You can ask them to give you 10 meters, 20 meters. Only length you can specify, not breadth. That is fixed. In this question, you have to decide how much, what length of tarpaulin you have to buy. Okay, the details about the conical tent is given to you. The conical tent should have a height of 8 meters and the base radius should be 6 meters. Okay. The conical tent should have a height of 8 meters and radius of 6 meters. So this is the requirement. You'll have to put up a tent of this height and this radius. Now you have to decide the length of the tarpaulin you need to purchase. You're going to the store. What will be the length of the tarpaulin you have to purchase? That's what you have to find. And supposing you need to buy, say, some 2 meters. We'll just assume, okay, some 2 meters. You should buy 20 centimeters extra because that's given in the question. Extra length. Assume that the extra length of the material, extra length, not area, extra length of the material, for stitching the margins and the wastage which is incurred in cutting. The wastage which will be incurred in cutting the material and for stitching of the margins. For all this, you should keep an extra fabric of 20 centimeters. There should be a reserve, 20 centimeters for all this, stitching margins and wastage in cutting. So if you actually need 2 meters, you must buy 2 meters and 20 centimeters. Whatever you need, buy 20 centimeters extra. That's the other thing given in the question. So in the question, what you have is you have the radius of the tent, the height of the tent. you have to purchase tarpaulin from the store. So to the shopkeeper, you should specify the length of the tarpaulin you need. And how much of a you decide to buy, you must buy 20 centimeters extra. And I was telling you that the fabric, the width of the fabric is fixed, and that is 3 meters. In the store, the width of the fabric is fixed. That is 3 meters. The width of the tarpaulin is 3 meters. The very simple question. All that you have to do is find the curved surface area of the tent. Curved surface area of the tent. Okay, the formula is pi RL, 3.14 into R, 6 into L. You will find it will be 10. Okay, and the answer is 188.4. 188.4. This much, this is the area of tarpaulin you need to make this tent. This is the area. Now you cannot go and tell the shopkeeper the area of material you need. You should tell him the length. So if you need this area of tarpaulin, area of tarpaulin, because whatever is the CSA is the area of the tarpaulin you need. So the area of the tarpaulin is 188.4, and tarpaulin is rectangular. So L into B is equal to 188.4. Length into breadth is 3. It's given in the question. The breadth of the tarpaulin is 3 meters. Is equal to 188.4. So L is equal to, see here, L is equal to 188.4 by 3, which is 62.8 meters. So you have to buy 62.8 meters of tarpaulin. This is the length of the tarpaulin you need to buy. But what is wastage? 20 centimeters. This is in meter. But wastage is given in centimeters. So convert that to meters. Add 62.8 plus 0.2. So 63 meters. You need to buy a total length of 63 meters of tarpaulin to put up a conical tent of radius 6 meters and height 8 meters. So you can see here breadth of the tarpaulin that will be used here. Breadth of the tarpaulin. Breadth of the tarpaulin is 3 meters. This is the height of the cone. This is the radius of the cone. Because we have to find the CSA, you'll have to find L, root of h square plus r square. And that's 10. Next, find CSA pi RL. This is the area of the curved surface area of the tent, which is also the area of tarpaulin you need. That means L into B, because tarpaulin is rectangular. So L into B is equal to 188.4. And B is 3. Breadth of the tarpaulin, wide, 3 meters wide, meaning width. So this is the length of tarpaulin you need, but you need to have a provision of 20 centimeters for margins and wastage. Convert this to meter because this is in meter. You cannot add, no, 5, supposing 5 kgs and 5 grams. Can you add and say 10? No. How can you add two numbers with different units? So 5 kgs is 5,000 grams. 5,000 grams plus 5 grams. 5,005 grams. Or you convert this to kilograms. Okay. So 20 centimeters is 0.2 meters. Then add, this is the length of the tarpaulin you need to buy. Yeah, sorry, children. So in this question, yeah, so a tomb is conical. A conical tomb okay, so it's about a conical tomb. The slant height is given to you and the diameter is given to you. Slant height 25, diameter is 14, which means radius is 7. And it's a conical tomb. You need to find the cost of whitewashing. It's curved surface. It's given very clearly, curved surface. Then you should find the curved surface area. Pi RL. Pi RL. The values of R and L given to you. And that is 550. What's the cost of whitewashing? For 100 meters square, it is 210 rupees. For 100 meters square, it is 210 rupees. The cost of whitewashing 100 meters square is 210 rupees. So 1 meter square will be 210 by 100. So the cost of whitewashing 550 meters square will be 550 into 210 by 100. Because 1 meter square is this. So 550 meters square will be 550 into this one. The question is about a conical tomb. Slant height given, radius given. You need to find the cost of whitewashing the curved surface. To find the cost, you should first find how much area you have to whitewash. How much area should be whitewashed? For that, you should find the CSA because curved surface. Formula, all values given. This is the CSA. And what is the rate? For 100 meters square, it is 210 rupees. So for 1 meter square, 210 by 100. So this is for 1 meter square. So for 550 meters square, it will be 550 into 210 by 100. The slant height and the base diameter of a conical tomb are 25 meters and 14 meters respectively. Find the cost of whitewashing its curved surface at the rate of rupees 210 per 100 meters square. In a joker's cap, the head of the person will fit here, right? The head of the person. So there'll be no material used to cover the circular portion. Here, no material is used because you will have to put it on. The person has to use it on the head. So this portion is empty. The circular portion is not covered with cloth. So in a joker's cap, where is the material used? Only to make the curved surface area. In a joker's cap. Okay. Supposing you're stitching a cap. Where will you use material? Only to make the curved surface area. Will you cover the circular base also with material? No, then how will you wear the cap? So here, the circular portion, you will not cover it with material. The material will be used only to make the curved surface. So again, a simple question. See here. A joker's cap is in the form of a right circular cone. Radius is given, height is given. Find the area of the sheet. So you're making it out of sheet, not cloth, but sheet, like the birthday conical caps used in birthdays. It's made of, this cardboard or some kind of a sheet. So find the area of sheet required to make 10 such caps. 10 caps. So you should not find volume here. Volume is to fill. If you're pouring something inside the cone, then it is volume. Otherwise, it is area. Supposing you have a cone, you have an ice cream cone, and you have to find how much ice cream can be, filled into that cone. Then you should find volume. because you're doing something inside the cone. You're filling the cone with something. That's volume. If you're doing something with the surface, then it's area. So clearly the sheet is used to make the surface, the curved surface of the cap. So find the area of sheet required to make one cap, which is a CSA pi RL. This is to make one cap into 10 caps. Listen carefully. R is given, H is given in the question. Why should we find L? Because to find curved surface area, this is the formula, and we need L. So find L, root of H square plus R square. So in the joker's cap, the sheet will be used to make the curved surface. The base of the cap is open. No sheet will be used there. So that means you should find only the curved surface. Area of sheet needed to make one cap, pi RL. 10 caps into 10. So on the road, so you're going, you're riding behind, somebody on a vehicle. You're going on the road, and so some work is going on. There's some work in progress here, There's some work in progress. You can see some 10, 15 men working here. So on the road, you'll see some conical structures like this on the road. Okay. So you'll have to go carefully. You'll have to go carefully. That means this part of the road is barricaded, meaning it is separated from the rest of the road because there is some work in progress. You're not supposed to use this part of the road because there's some work in progress there. So to, inform people on the road, people on the vehicle, that they're not supposed to use this part of the road, it's barricaded, it's separated from the rest of the road using conical structures, normally painted red. Conical structures normally painted red. So a bus stop is barricaded, meaning it's separated from the remaining part of the road by using 50 hollow cones. Hollow meaning the base of the cone is this one, no, it's open. This is open. That means it's hollow. This is open. The material is used only here. Here there is no material. When you lift the cone and see it under the cone, this part is open. You can look inside the cone. A bus stop is barricaded from the remaining part of the road by using 50 hollow cones made of recycled cardboard. Each cone has a base diameter, so radius is 20 and height 1 meter. Make sure you have all the all the values in the same unit, either all in meter or all in centimeter. But you can see here it's given rupees 12 per meter square. So you have everything in meter. Rupees 12 per meter square. So we'll have all the values in meter. Okay, so diameter is 40 centimeters, which means radius is 20. 20 by 100 meters, which is 0.2 meters. Radius is 0.2. 20 centimeters, 20 by 100 meters. So 0.2 meters. Radius is 0.2. Height is 1 meter. The outside of each of the cones is to be painted. The outside of each of the cones has to be painted, and the cost of painting is given to you. For 1 meter square, 12 rupees. 2 meter square, 24 rupees. 3 meter square, 36 rupees. What will be the cost of painting all these cones? Instruction pi 3.14, and when you work, you will come across this one, square root of 1.04. That value is given to you, 1.02. Okay. What's the radius? 20 centimeters, which is 20 by 100 meters or 0.2 meters. Height 1 meter. L is equal to square root of h square plus r square, which is equal to square root of 1 square plus 0.2 square, which is equal to square root of 1 plus 0.2 into 0.2. 2 twos are 4. 2 decimal places, 0.04, because 2 decimal places, 0.04, 0.04, which is square root of 1.04. And the square root of 1.04 is given as 1.02. So slant height is 1.02. Slant height is 1.02. Now you need to find what is painted. The curved surface is painted. How do we know curved surface? Because the bottom is not covered with, that recycled paper. It's given hollow cone. Hollow cone meaning the cardboard is used only to make the curved surface. Hollow meaning the cardboard is used to make only the curved surface. The circular portion of the cone is not covered with cardboard. It's open. So the cardboard is used to make only the curved surface. So we have to find only the curved surface of the cone. Radius in meter, height is 1 meter, L, CSA of 1 cone, 50 cones into 50, 1 meter square. To paint 1 meter square, 12 rupees. So to paint this area of 50 cones, it will be into 12. CSA, because the material, the cardboard is used only to make the curved surface. The circular part is empty. It's a hollow cone. Should find the CSA of 1 cone, multiply by 50 to find the CSA of 50 cones. So this is the total area that is to be painted. Now to paint 1 meter square, 12 rupees. So to paint this much meter square, it will be into 12. But to find CSA, you need R and L. We have R and we have H. We don't have L. So you'll have to find L. And while finding L, you get square root of 1.04, which is given, whose value is given in the question, 1.02. So save time there. So that's about the first exercise. Okay, so this is the next exercise, 11.2. It's about a sphere. So we'll see the formula for sphere and hemisphere. Half of a sphere is a hemisphere. You know how spherical objects look. Okay. Sphere, hemisphere. Volume 4 by 3 pi r cubed cubic units. Volume is half of this one. Half of this 4 by 3 divided by half. Divided by 2, sorry. Divided by 2, I'm sorry. 4 by 3 divided by 2. Half of it, right? So it'll be 4 by 3 into 1 by 2. Hemisphere, half of a sphere. So 4 by 3 divided by 2, which means into 1 by 2. So 2 ones are 2s are. So 2 by 3, 2 by 3 pi r cubed. Cubic units. Now for a sphere, there is no difference. CSA, TSA, both are the same. So surface area, there's nothing like curved and total here. It's just surface area. So surface area or the total surface area is equal to 4 pi r square units. Hemisphere has both CSA and TSA. So this is the curved surface area. This is the area of circle. Area of circle. So curved surface area is equal to 2 pi r square units. Total surface area is equal to the curved surface area 2 pi r square plus the area of the circle. Total surface area plus the area of the circle pi r square, which is 3 pi r square units. That is the CSA plus the area of the circle. CSA plus area of circle. CSA is 2 pi r square plus area of circle. Important in a hemisphere, the height is equal to its radius, r. In a sphere, the height is twice the radius. Height of the sphere is equal to 2 times the radius. Height of the sphere is equal to 2r. Here, height of the hemisphere is equal to the radius. That is the depth of the hemisphere. The depth of the hemisphere, is equal to the radius of the hemisphere. Okay. Let's have a look at the formula. 4 by 3 pi r cubed, 2 by 3 pi r cubed. Then 2 pi r square, 3 pi r square, 4 pi r square. 2 pi r square is CSA of hemisphere. 3 pi r square, TSA of hemisphere, total surface area of hemisphere. 4 pi r square, total surface area of sphere. 2 pi r square, 3 pi r square, 4 pi r square. 4 by 3 pi r cubed, 2 by 3 pi r cubed. Direct question. Just write the formula and calculate. Again, a direct question. Meaning, you have to find CSA. You're given the value of R. So this is about a motorcyclist performing in a circus. You must have seen that, no? A spherical cage, a spherical cage made of iron, a spherical cage made of iron, you know. So the motorcyclist, he's inside the cage. He's inside this spherical cage, and he'll do rounds. No, he'll do rounds without falling. He'll go on the surface of the inside surface of the spherical cage. Okay. So the question is about that. The hollow sphere in which the circle, sorry, the hollow sphere in which the circus motorcyclist performs his stunts has a diameter of 7 meters. Find the area available to the motorcyclist for riding. Find the area available. So it's a sphere, total surface area. There's no other area, no? For a sphere, total surface area. What area is available? Total surface area is available. All this area inside the sphere is available. So the formula is 4 pi r square. TSA, 4 pi r square. Diameter is 7. So radius is 7 by 2. Or you can also take 3.5. So here a hemispherical dome of a building needs to be painted. Painted means area. But this is hemispherical. A hemispherical. This was a sphere. The hollow sphere. This is hemisphere. A hemispherical dome of a building needs to be painted. If the circumference of the base of the dome, the circumference of the base. So this is the dome. This is the dome. This is the base. It's a hemispherical dome. This is the base. The circumference of the base. The base is circular. Base is circular. So what will be the circumference then? 2 pi r is equal to 17.6. If the circumference of the base, what is the shape of the base? Circle. So circumference of the circle. Circumference of the base is circular. So circumference of the circle, 2 pi r, is 17.6. You must find the cost of painting it at the rate of 5 rupees per 100 centimeter square. So what is to be painted? You can see the dome. You can see that blue color on the top. So the dome, the curved surface area of the dome has to be painted. The curved surface area of the dome has to be painted. Because the bottom, this one will not be covered. This one, when you get inside the building, you can see, supposing you go and see the door is open. The door is open when you get inside the building. And when you look at the ceiling, the circular portion will be open. You can only see the curved surface area like this. You can see the dome like this here, inside. That circular portion will not be covered. It'll be like empty. You can only feel that circular shape. So whether you're painting inside or outside, you can only paint the curved surface area. It may be the inside curved surface area or the outside curved surface area. But only the curved surface area you can paint. Because the bottom circle will not, you cannot paint that. There'll be nothing there. You can only see the circular shape. So you'll have to find the CSE of it's a hemisphere, so you'll have to find the CSE of the dome. 2 pi r square. 2 pi r square is the formula. But r is not given. But there is some other information to find r. 2 pi r is given. 2 pi r is 17.6 is given. Circumference 2 pi r is 17.6. So you can work this and find r. 2 into 22 by 7 into r is equal to 17.6. So work this and find the value of r. Then find the CSA, which is 2 pi r square. Then for 100 meter square, 5 rupees. So for 1 meter, sorry, for centimeter square, okay. So that means this area you would have found in meter square. You should convert that to centimeter square. Because the cost is given per centimeter square, per 100 centimeter square. So convert the area you got in meter square to centimeter square. Then for 100 centimeter square, it is 5 rupees. For 1 centimeter square, it will be 5 by 100. And then for whatever answer, supposing you got some 500 as the answer. So 500 centimeter square, it will be 500 into 5 by 100. That is how you got the answer. So circumference of the circular base, 2 pi r is 17.6. I've changed 17.6, this decimal to a fraction, 176 by 10. And then you have to cancel. See, cancelling part, some places I show, some places I don't show because it'll like take up so much space if I do it. If I cancel, no, if I do a lot of simple cancellation, I'll show. But when there's lots to cancel, then, it'll take up so much space. This one will become so big. So I don't show when there's a lot of calculation, I don't actually show. So you can cancel and then you get 2.8 meters. Why 2.8 meter? Because this is 17.6 meter. So radius is 2.8 meter. Convert that to centimeter. I've done it in 2 ways. I explained this one actually for you. I explained this one. Let me do this. So when you cancel, you get 2.8 meters. So now find the CSA. 2 pi r square. 2 pi r square. So this area is in meter square. How do you convert that to centimeter square? Multiply by 100 2 times. Why? Meter to centimeter, you should multiply by 100. Meter square to centimeter square. You should do the same thing 2 times. Whatever you do it 2 times. Meter to centimeter into 100. Meter square to centimeter square into 100 into 100. So now it's converted to centimeter square. Now coming to the cost. 100 centimeter square, 5 rupees. 1 centimeter square, 5 by 100. So this centimeter square will be this value into 5 by 100. Using the circumference, find the radius. Once you find the radius, find the curved surface area. You get it in meter square. Multiply by 100 2 times to convert it to centimeter square. Then find the cost. Alternatively, instead of finding the area in meter square, you can directly convert this radius to centimeter. You can also change this also to centimeter directly. See, wherever you can change this itself to centimeter. I have changed this radius 2.8 meters to centimeter, 280 centimeter. So now when you find 2 pi r square, you will get the answer directly in centimeter square because radius you've substituted in centimeter. So you'll get the answer directly in centimeter square. So now 100 centimeter square, 5 rupees. 1 centimeter square, 5 by 100. This centimeter square will be this one into 5 by 100. So the question is, a hemispherical dome of a building needs to be painted. The curved surface area has to be painted. So for that you need only radius value, nothing else you need. But that's not given. The circumference of the base is given to you. Circumference of the base meaning circumference of the circle. So using that, you can find the value of R. What is the cost like? For 100 centimeters square, 5 rupees. So find the area in centimeter square, not in meter square. Because for 100 centimeters square, 5 rupees. So find the area in centimeter square. You can also do it like this. They found it in meter square and then converted the area in meter square to centimeter square like this. Direct questions. So you should find the surface area given the diameter. So radius is half of that. Surface area of sphere formula 4 pi r square. TSA of hemisphere. Formula 3 pi r square. Hemisphere, TSA, 3 pi r square. Pi is 3.14. 3 into 3.14 into 10 into 10. Okay. In this question, the radius of a spherical balloon increases from 7 centimeters to 14 centimeters as air is being pumped into it. Find the ratio of the surface areas of the balloon in the two cases. You don't have to find the surface area. You should just find the ratio of the surface areas. Find the ratio of the surface areas of the balloon in the two cases. The first case is when the radius of the sphere or the spherical balloon is 7 centimeters. The second case is when the radius of the spherical balloon is 14 centimeters. These are the two cases. In the two cases, meaning case 1, radius 7 centimeters of the spherical balloon. Case 2, radius is 14 centimeters. The radius of the spherical balloon is 14 centimeters. You don't have to find the surface area. The question is not to find the surface areas of the balloons in the two cases. Find the ratio of the surface areas. So you can directly find the ratio. Directly find the ratio. Okay, so supposing we call the R as 7 and R as 14 like this. Radius. So the balloon is like this. The spherical balloon. Okay, so it's not like this. It's like this. Then you blow more air into it, it becomes like this. Correct? It's a balloon. You blow air into it. In the first case, the radius is 7. So the balloon is like this. Then you blow more air into the balloon. So then it grows in size. It becomes like this. Now this is the surface area. This one is the surface area. This one is the surface area. Supposing the surface area here is, just for example, some 100 centimeters square. Supposing the surface area here is, say, some 800 centimeters square. So what's the ratio? 100 by 800. 1 by 8. 1 is to 8 is the ratio. They want you to find this ratio. So it's a sphere surface area sphere 4 pi r square. This is when the radius is 7. When the radius is 14, 4 pi r square. This ratio you should find. Cancels. R 7, r square 7 into 7. Capital 14, r square 14 into 14. 7 ones are 7 twos are. 1s are 2s are. 1 by 4. So 1:4 is a ratio. So when the radius is 7, if the surface area, say, for example, 100 centimeters square, when the radius is 14, the surface area will be 400 centimeters square. The ratio is 1:4. If it is 100 centimeters square, it will be 400 centimeters square. If it is 200 centimeters square, it will be 800. 4 times it will be 800 centimeters square. 1:4 is the required ratio. Online children, use the emoji, raise your hand. Gayatri, Harsha, Surya, Anita, Sachin, Yarni. Divitra, are you there? Okay. A hemispherical bowl made of brass has inner diameter 10.5 centimeters. Hemispherical bowl. Inner diameter. Find the cost of tin plating it on the inside. You want to tin plate it inside. It's a kind of silver color coating. Okay, so that when you cook, the food does not get burnt. Like we have the non-stick cookware today. So in earlier days, brass vessels used to be tin plated. A thin silver coating, not silver. Okay, so silver colored, so which is tin. So the inside will be tin plated so that the food does not doesn't get stuck, doesn't get burnt. So you need to find the cost of tin plating it on the inside at the rate of rupees 16 per 100 centimeters square. So just imagine, no, you have a hemispherical vessel. And the vessel means it's open at the top. When it's a vessel, that means on the top it's open. Unless it's given that the vessel has a lid. See, when we say tumbler, I say tumbler. Tumbler means it will be open at the top. If your tumbler has a lid, you should say that my tumbler has a lid. Otherwise, tumbler means it does not have a lid. A cylindrical tumbler, juice tumbler. The base, the bottom is covered. The top is open. The top will be open. This is covered. Similarly, this hemispherical bowl, it's open at the top. The mouth is open. So where will you tin plate? You'll tin plate here. Only the CSA. Only the CSA you'll have to tin plate. So find the curved surface area, 2 pi r square. Two pi r square. Find the curved surface area, the inside area of the bowl, 2 pi r square. Then for 100 centimeter square, 16 rupees. 1 centimeter square, 16 by 100. So for this centimeter square, it will be into 16 by 100, which is 27.72. Diameter was given. So radius is diameter by 2. Inside area meaning the curved surface area. Total surface area means it will include the circle on the top for a hemisphere. If you meaning total surface area meaning if you're doing something on the circular portion also, but here the circular portion is empty, meaning it's open. There is no material there. So you'll have to tin plate only the inside curved surface area. Just find the area and then the cost. So you can see here the radius of a sphere whose surface area is 154. Find the radius of a sphere whose surface area is 154. So surface area is given to you. You don't have to worry if it is curved surface area or total surface area because it's a sphere. If it was a hemisphere, yeah, then we have this question. Hemisphere, so is it curved surface area or total surface area? Because both are different. 2 pi r square, 3 pi r square. But this is sphere. Sphere, CSA, TSA, both are the same. So surface area of the sphere is given 154. That means 4 pi r square is 154. So r square is equal to, I can just include one step for you. So 4 into 22 by 7 into r square is equal to 154. 4 into 22 by 7. 4 into 22 by 7 into r square is equal to 154. So r square is equal to 154 reciprocal. 7 by 22 reciprocal. 1 by 4. So r will be equal to the square root of 7 into 7 by 4. So from 2 sevens, 1 7 comes out and the square root of 4 is 2. From 2, you can even multiply 7 7s are 49 and the square root of 49 is 7 and the square root of 4 is 2. 7 by 2, which is 3.5. So in this question, the surface area of a sphere is given to you. Because it's a sphere, we don't have to worry if it is CSA or TSA because there's only one thing, which is a surface area, and that is 4 pi r square. So 4 pi r square is given 154. From this, you should find the radius of the sphere. So 4 pi r square is equal to 154. 4 into 22 by 7 into r square is equal to 154. Solve this equation to find the value of r. The diameter of the moon is approximately 1/4 of the diameter of the earth. Find the ratio of their surface areas. The diameter of the moon is approximately. So you should now, when we work, we'll have to take equal to only. Now, approximately cannot be like worked approximately. So we'll have to take it as the diameter of the moon is equal to 1/4 the diameter of the earth. Find the ratio of their surface areas. Okay. So diameter of the moon. Let me take this 2r. R is radius, right? So 2r is the diameter. R is radius. What is diameter? 2 into r is diameter. So for the moon, we know the size of the moon is smaller than the size of the earth. The size of the moon. See, now the earth is not a perfect sphere. For the sake of working, we just take it as a sphere. Otherwise, the earth is not a perfect sphere. Can anyone tell me the shape of the earth? What is the shape of the earth?
Geoid, ma'am.
Correct. Louder once again.
Geoid, ma'am.
Okay, it's an oblate spheroid. The shape of the earth. One second. Not getting the point. 1 second. So it's somewhat it's spherical, but it's kind of rounded at the corner. It's not a perfect sphere like this. It's an oblate spheroid. But here we take the moon and the earth as perfect spheres. Okay. The diameter of the moon. So I said radius is r. So the diameter is 2r. Moon being smaller than the earth, we'll take small r here and capital R here. So diameter will be this one for the moon and this one for the earth. The diameter of the moon is equal to 1/4 of diameter of the earth. Diameter of moon is approximately 1/4 of diameter of earth. Is given. This is given. Diameter of moon is 2r is equal to 1/4 of diameter of the earth 2r. So the earth is bigger, no? You can cancel the 2's on both the sides. You can simplify this 2 and this 4 also, whatever. So 2 gets cancelled on both the sides, and when you cross multiply, you get r into 4 is equal to capital R. So capital R is equal to 4r. That means the radius of the earth is approximately 4 times the radius of the moon. The radius of the earth is approximately 4 times the radius of the moon. Okay. The question is to find the ratio of their surface areas, which means we have to find 4 pi r square by 4 pi r square, because ratio, we have to find ratio. You don't have to find their surface areas, find the ratio directly. Ratio of their surface areas. And we are working with spheres. Surface area 4 pi r square. So you need to find this ratio. 4 pi gets cancelled. And r square by, what is r? It's 4r, right? But this r square, that means it's r into r. R square means r into r. So it is 4r into 4r. So r into r is r square and r square, they get cancelled. So 1 by 16 is the required ratio. The required ratio is 1 by 16. Okay. So here a hemispherical bowl is made of steel, 0.25 centimeters thick. So imagine a hemispherical bowl. The material, steel, it's thick. It's 0.2 centimeter. Oh my God. 0.25 centimeters thick. So 1 centimeter is what? 10 millimeters. And 0.25 meaning 2.5 millimeters thick. So that's barely anything. I'm just showing you. Okay, so it's thick. Okay. It's thick. This thickness is 0.25 centimeters. The inner radius meaning from here to here, the inner radius, till the inner wall. The inner radius, because the material is thick, you'll have two radius. One is from the center to the inner wall, the other is from the center to the outer wall. This is capital R. This is small r. If the material is not thick, if it's very thin, both the radius, the small r, capital R will have the same value because the material is not thick, no? So both the values will be the same. If the material is thick, then you'll have different values for the two r's. From the center to the inner wall is small r. And from the same center to the outer wall till here is capital R. So that means what? Small r plus the thickness is capital R. Small r, here, from here to here is small r. And from here to here is the thickness of the material. So small r plus the thickness is capital R. Is capital R. So capital R is equal to small r plus the thickness. So what is thickness? It is basically the difference between the two radii. Thickness is outer radius minus the inner radius. Thickness is outer radius minus the inner radius. And the inner radius will be the outer radius minus the thickness. Everything from this one. Just transpose and you will get all the relations. Capital R is equal to small r plus W. Small r is capital R minus W. W is thickness. W width. W is equal to width or the thickness. W is equal to capital R minus small r. All right. So hemispherical bowl is made of steel, 0.25 centimeters thick. The inner radius is 5 centimeters. So the outer radius will be 5 plus 0.25. That is small r plus w, which is 5.25 centimeters. Find the outer curved surface area of the bowl. See, the curved surface area of a hemisphere is 2 pi r square. Curved surface area of a hemisphere is given by the formula 2 pi r square. If you have to find the inner curved surface area, then it is 2 pi small r square. Outer curved surface area 2 pi capital R square. Curved surface area formula is 2 pi radius square. 2 into pi into radius square. Inner CSA, inner curved surface area, inner radius. Outer curved surface area, outer radius. WR curved surface is 2 pi r square. Outer means capital R, inner is smaller. A right circular cylinder just encloses a sphere of radius r. A right circular cylinder just encloses a sphere of radius r. That means the sphere just fits into the cylinder. The sphere just fits into the cylinder. Okay. Find surface area of the sphere. Surface area of the sphere, CSA, TSA, both are the same. So surface area is 4 pi r square. CSA of the cylinder, curved surface area of the cylinder. Cylinder we have seen last year. In class 8, we have seen cube, cuboid, and cylinder. Among plane figures, we have seen circles, triangle, parallelogram, rhombus, trapezium, kite, of course, square, rectangle. Among solids, we have seen cube, cuboid, and cylinder last year. The curved surface area of a cylinder is given by the formula 2 pi r h. 2 into pi into radius into height. 2 into pi into radius of the cylinder into height of the cylinder. Radius of the cylinder into height of the cylinder. So 2 into pi into, what is the radius of the cylinder? R only. Whatever is the radius of the sphere is the radius of the cylinder also. And what's the height of the cylinder? It's 2r. We can see that. R plus R. 2r is the height of the cylinder. This is the height of the cylinder. From here to here. This is the height of the cylinder. This is the height of the cylinder. And clearly the height of the cylinder is R plus R. 2r. So 2 into pi into radius of the cylinder, R into height of the cylinder, 2r. Which gives us 2 to the 4 pi r square. 4 pi r square. It's the same, 4 pi r square. So this is 4 pi r square. This one is also 4 pi r square. Third sub question is to find the ratio of the areas obtained in 1 and 2. ratio of the areas obtained in 1 and 2 is 1:1. 1:1.